Hi all, this video is going to discuss about tutorial discussion, chapter 3, Electrochemistry, question 1 to question number 8. So, first of all, right, we must know how to refer the standard electrode potential, E node, cell, or the standard reduction potential list. Okay, based on here, all are the half reaction of the cell, okay, all undergo reduction. That's why we call it standard reduction potential. Okay. If you base on here, right, okay, when going down, right, increasing strength of reducing agent, you must have a concept. Reducing agent means undergo oxidation, and then from bottom to top, increasing strength of oxidizing agent means undergo reduction. Okay, meaning that more positive, okay, undergo reduction, happen at cathode, and then more negative, undergo oxidation, happen at anode. So this is the main concept you have to know for this chapter. Next, question number 1, define galvanic cell and half cell. So based on here, right, I think should be no problem for you all to define. And then a galvanic cell consists of an aluminium electrode in 1 molar aluminium nitrate and a lead electrode in 1 molar lead nitrate and a potassium chloride salt bridge. So draw and label the cell diagram, write the overall cell reaction, and calculate the standard cell potential, which electrode will increase in wave. Explain your answer. Let's check it one by one. So first of all, right, galvanic cell means all electrochemical cell for generating electricity to the use of the spontaneous redox reaction. Okay, you have to know, right, electrochemical cell, there are two. One is galvanic cell, and another one is electrolytic cell. So you must know the difference among these two different cells. And then half cell is a portion of an electrochemical cell in which a half reaction takes place. The half reaction actually is referred to reduction happen at cathode and then oxidation happen at anode. And then when these two equations combine, and then we call it as overall cell equation. Then calculate the standard cell potential. Okay, we need to write out the formula as well. Okay, so now we check it one by one. So this is the draw and label a cell diagram. First, you have to label the anode is aluminium. Okay, please add on. Madam 1, you all write down aluminium solid right out the face. Aluminium solid with negative terminal. And then lead PB solid with positive terminal. Okay. So madam, if you check, right, there is a method I teach you all before. You can remember like this. Cathode, positive, anode, negative for galvanic cell. Okay, Kepang. Okay, another one is Kanape, cathode negative, anode positive for electrolytic cell. So this one we focus on galvanic first. After that, we must label the electrolyte. Okay, again, aluminium nitrate must write out aqueous and its concentration 1 molar. Lead nitrate aqueous with concentration 1 molar. Okay, must state the solution, the phase of the solution, and the concentration of the solution. Then next is about the salt bridge. Since the salt bridge is given is KCl, we just label salt bridge KCl. And then the flow of electron is fixed from anode to cathode. Okay, from anode to cathode. And then don't forget label the voltmeter as well. So this is the draw and label the cell diagram. Next, for the calculation part, okay, you just write down anode undergo oxidation. That's why you check the oxidation number from 0 become positive 3. And then this one undergo reduction for cathode from positive 2 change to 0. And then over here, please take note, 3 electron, 2 electron. The number of electron is different. That's why you have to make sure that the number of electron become the same, and then so that you can cancel off. So that's why after times 2, so it's 2 aluminium solid, 2 aluminium, 3 plus ion, and then this one 3 lead ion, and then 3 lead solid. Here, please take note. Then next calculation, formula, substitution, final answer with unit. Okay, you just straight away take the value based on the standard reduction potential. You check. Okay, what is the standard reduction potential for lead, and then what is the standard reduction potential for aluminium, and then substitute. Then you will get this answer. the positive negative sign insists and then the unit insists. Please take note. Okay, based on the equation, right, actually you can check which electron will increase in wave. You check. This one become aluminium ion. This one become lead solid. Automatically we know that solid, okay, for cathode, is formed in cathode. So the answer is cathode lead. Because Pb2 plus ion in the solution undergo reduction to form lead solid that deposit on the cathode. Actually, right, there is another method to solve the part B2. Okay, as I mentioned before, right, times 2 times 3, right, you have to take note, okay, while we times 2 times 3, right, okay, the value of the standard reduction potential won't change, okay, the standard reduction potential won't change. But if you check for anode undergo oxidation. So this one is from 0 become positive free oxidation, meaning that this is not standard reduction potential. Okay, reduction, the name of the cell is standard reduction, but in this case is oxidation. That's why the sign have to change to positive. Initially the value is negative 1.66. While we put in the value over here, right, in oxidation, right, this is one have to change the sign. Okay, that's why there is a formula. E node cell equal to E node oxidation plus E node reduction, and then the E node oxidation have to change sign. Okay, so meaning that the negative change to positive, then you get the same answer. Okay, cathode you just remain the same because this one is reduction. So then you sum up both E node oxidation plus E node reduction, you get the E node cell equal to positive 1.53 volt. So this is method 1 by using E node cell equal to E node cathode minus E node anode. Another method is E node cell equal to E node oxidation plus E node reduction, but the E node oxidation must change the standard reduction potential sign because this one is undergo oxidation. Okay, I hope you all get it. Okay, so I encourage you all, right, every time when you write down the anode half cell, okay, you can write down the anode oxidation, and then the cathode half cell, you can write down the anode reduction, and then combine overall anode cell, and then you double check this value with applying this formula, sure we'll get the same answer. You just cross check. Again, remember, positive sign insists, unit insists. Question number 2, standard electrode potential for silver plus silver and Pb2 plus Pb is given like this. Okay, you have to take note. The blue color, positive 0.799 volt is more positive, meaning that silver is cathode. And then the green color, negative 0.126 volt, meaning that this one is anode. So determine the anode and cathode should be no problem for you all. And then number 2, calculate the standard cell potential, meaning that you have to apply the E node cell equal to E node cathode minus E node anode. Let's check the answer for 2A. Okay, yes. More positive, undergo reduction, so it's cathode for silver. Okay, you have to write down it's silver only because it refer to anode, cathode is referred to the electrode. Same for anode, you have to write out Pb. Okay, for B, you have to apply the formula since you know the value is given. Okay, cathode positive 0.799 volt and then minus negative 0.126 volt. So you just substitute formula, substitution, final answer with unit. Okay, so again, positive sign, unit would insist. Now for B, okay, so the E node cell is given. And then the standard reduction potential for CO2 plus is negative 0.28 volt. Okay, over here we're not sure, okay, the standard reduction potential for CE. So meaning that we have to base on this formula to find it. Okay, meaning that this one is given. And then, okay, over here very obvious. Okay, this one undergo reduction. So undergo reduction means more positive happen at cathode. So this one we're not sure. Okay, and then this one is given, which is negative 0.28 volt. So we can substitute. Okay, so over here, right, the question not necessarily ask us to find the E node cell. We can find out the E node cathode or E node anode as well. Okay, like mathematics, 1 plus 1 equal to 2. Can ask you to find the 1 or ask you to find the 2. So yes, okay, formula. This is what I say. This one we're not sure. So just substitute everything, you get the answer. Positive 1.61 volt for the E node cathode means the CE 4 plus slash CE 3 plus. Okay, this is the E node. Okay, for CE 4 plus, CE 2 plus equal to this value. Okay.
Okay, now we look at the strength of oxidizing agent and reducing agent. Okay, first of all, you must always have this concept. Okay, oxidizing agent undergo reduction. The E node reduction, right? The standard reduction potential with more positive value. And then reducing agent undergo oxidation, the standard reduction potential with more negative value. So this is the basic concept we need to know. Then, if you check, increasing strength as reducing agent. Reducing agent, you always relate with oxidation. Oxidation, we choose a more negative value. Okay, so this one has the highest negative value, meaning that, okay, that's why when going down for these three species, the strength of reducing agent increase. Okay, automatically, okay, the strength of oxidizing agent increase from bottom to top. Okay, because oxidizing agent have more positive value. Okay, this one has more positive value if compared to sodium and calcium. Okay, so if you check, the strength of oxidizing agent is referred to the reactant. Okay, because Mg2 plus become magnesium. So this is undergo reduction with more positive value. But strength of reducing agent you have to check is with oxidation, meaning that calcium undergo oxidation become calcium 2 plus. Okay, that's why calcium solid is the reducing agent. Okay, then if we compare in terms of standard reduction potential, how are we going to determine which one is oxidizing agent and which one is reducing agent? Because you have to take note, if the question asks about strength of reducing agent, if you write down Ca2 plus, right, it's wrong. Okay, it's wrong because Ca2 plus over here, okay, is undergo reduction. If undergo reduction means it is a oxidizing agent. But now we look at strength of reducing agent. Reducing agent meaning that the reaction must undergo oxidation. So calcium is the reducing agent. So we always have to remember, if in the standard reduction potential table, oxidizing agent refer to reactant only. And then reducing agent refer to product only. Okay, please take note. This one we're talking about the standard reduction potential case. And then this case is redox reaction. That's why both of the oxidizing agent and reducing agent is at the reactant side, because this one is redox reaction. Just now is standard reduction potential list. So now let's look at question 3 based on the cell notation below. Okay, this is another form. Previously we learned about half cell, overall cell, and then this one is cell notation. Okay, cell notation, we have to write out the anode first. Anode undergo oxidation, silver solid. Okay, this vertical line is referred to phase boundary, and then double line is referred to salt bridge. Okay, Ag plus oxidation, and then M3 plus become M solid. This one is reduction, so cathode, and the E node cell equal to positive 1 volt. So write a balance equation for the spontaneous reaction. As I mentioned before, if you want to write the balance equation, right, we have to write out the anode and cathode, then overall cell reaction. And then when we write out the anode, right, there is only 1 electron, but cathode there are 3 electrons. That's why the whole equation for anode reaction have to times 3, and then so that 3 electron can be cancelled off and then combine. So this is the overall cell reaction. And then second question, right? Okay, name the oxidizing agent. Name the oxidizing agent. Just now write a balance equation. So name the oxidizing agent meaning that undergo reduction. So which one undergo reduction? Okay, this one undergo reduction. Reduction, yes, M3 plus is the oxidizing agent. And then calculate. Okay, calculate. So E node cell we know already is 1 volt. And then the standard reduction potential for silver is given. Okay, we have to apply the formula. E node cell equal to E node cathode minus E node anode. So over here we need to determine the E node cathode. Okay, so just do it as mathematics. You will get positive 1.8 volt. So the positive sign insists and then the unit insists. Okay, this is the standard electrode potential or standard reduction potential list. This one is very important. But during exam, right, this list is not given. They will give you the exam will give you the specific standard reduction potential. according to the question. But for the time being, you must know how to find out the standard reduction potential for certain species. So for example, question 4. Predict whether the following reaction will occur spontaneously in aqueous solution at 25 degrees Celsius. Assume that the initial concentration of the dissolved species are all 1.0 molar, means at standard condition. If at standard condition, right, we determine the spontaneity based on the E-node cell. If positive, yes, spontaneous. If negative, then non-spontaneous. So over here, right, we no need to determine which one is oxidation or reduction based on the standard reduction potential, because given we just solve this problem according to here. So you look at calcium solid become calcium 2 plus. So the blue color calcium solid, calcium 2 plus, the oxidation number increase. So this one is anode. While the red color, the oxidation number decrease, right? So this one undergo reduction is cathode. After you know, okay, which one is anode, which one is cathode, right? You have to apply the formula E node cell equal to E node cathode minus E node anode. Of course, now you have to search the standard reduction potential from the list I showed you just now, and then you substitute. Of course, you have to determine which one is anode or cathode. No need. In this case, you no need to determine. Why? Because we have to answer according to these four equations. Okay, so you know, right? Okay, cathode. So over here, cathode is undergo reduction. So CD. So CD, so negative 0.4 volt minus 2.87 volt. So you get positive 2.47 volt is spontaneous. Okay, now you try to solve the problem for B, C, D by yourself. Okay, you have to find out the standard reduction for each of the species and then substitute, and then you get the answer. So you just cross-check with my answer whether you get the negative 1.21 volt non-spontaneous or not. Okay, I remind you all again. Previously, yes, we know the concept about more positive cathode, more negative anode. So this is how you determine the anode or cathode. Okay, but in this case, you no need to determine because we have to answer according to the question. So we just based on the equation, okay, we know already which one is anode, which one is cathode. We just substitute to the E node cell equal to E node cathode minus E node anode formula, and then we check the value. If positive, spontaneous. If negative, non-spontaneous. Clear? We proceed for question number 5. Predict whether Fe3 plus can oxidize I negative to I2 under standard condition or not. So first of all, right, we must write down the equation. Okay, so based on here, right, iodine solid reduce become to iodide negative with the value positive 0.53 volt, and then iron 3 plus, okay, reduce will become iron 2 plus with positive 0.77 volt. Over here, right, okay, positive 0.77 more positive, so this one is cathode, and then this one positive 0.53 is more negative compared to 0.77, so this is anode. After you substitute, you get the answer positive 0.24 volt. So E node cell is positive value, so it's a spontaneous reaction. So Fe3 plus can oxidize I negative. Okay. Next, question 6. Okay, based on each pair, which one is better oxidizing agent? So first of all, right, oxidizing agent you must remember is undergo reduction, choose more positive value. Of course, you cannot simply tell me, oh, Br2 is a better oxidizing agent or Au3 plus is a better oxidizing agent. No, you have to find out the equation, the standard reduction potential equation, and then check which one more positive. If we compare, right, okay, go to search and then you get this is the standard reduction potential, this one more positive, so Au3 plus is the better oxidizing agent for this case. Okay, if you still remember, right, if compare in terms of standard reduction potential, okay, always refer to reactant. Okay, and then this case, okay, this one more positive, so this is the better oxidizing agent. And then this one, even though both have negative value, but we compare, right, this one more positive. So CD2 plus is a better oxidizing agent for C. And then D, okay, this is acidic medium, H+. This one is basic medium. If we check the value, acidic medium, okay, have more positive value. So, in this case, oxygen in acidic medium, okay, is better oxidizing agent. Clear? Always remember, in the standard reduction potential table, oxidizing agent, we just look at the reactant. Okay, now we go for which species in each pair is better reducing agent. Reducing agent, always remember, reducing agent undergo oxidation, we choose a more negative value. So if compare this one more negative, this one more negative, okay, and then compare these two, this one more negative, and then compare with these two, this one more negative. If you still remember, okay, if in the standard reduction potential table, reducing agent, we look at the product only, meaning that, okay, this one, and then this one is hydrogen, and then this one is Fe2 plus, and then this one is 2 bromide ion. Here, you cannot give lithium plus, this one cannot, because we just refer to product only. Clear? Okay, but while we compare, right, we still compare the value of standard reduction potential. Always remember, if you want to determine which one is anode, which one is cathode, we must compare the value in standard reduction potential. Make sure that the equation that you check, right, is undergo reduction. Na plus become Na, so 0. Positive 1 becomes 0. Here, please take note.
Okay, now we look at question number 8. The magnitude of the standard reduction potential of two metal X and Y are follow. Okay, given that this is X, this one is Y, and then the E node denotes only the magnitude, not the sign, meaning that, okay, 0.34 volt might be in positive or negative. Same for here, might be negative 0.25 volt or positive 0.25 volt. Okay, so now we have to base on the information to identify the standard reduction potential or the E node cell of X and Y. So when half cell of X and Y are connected, so if you base on this diagram, right, okay, before we proceed, one concept very important, you must always remember for the standard reduction potential, which more positive value it occur at cathode undergo reduction, and then for more negative value is oxidation happen occur at anode. So we must check the electron flow from which side. Normally is from anode to cathode. Okay, not normally, 100% is from anode to cathode. So first, when the half cell X and Y are connected, electron flow from X to Y. So meaning that the electron flow from X to Y. X to Y, meaning that X is anode, Y is cathode. Anode, okay, more negative. Okay, now we check the value for X and Y. Okay, X to Y, X should be more negative. X should be more negative. Okay, over here, right, this is 0.25 volt. Okay, this is 0.34 volt. Okay, meaning that this one is more negative value. So suppose is, if you compare, actually this one more positive. So meaning that X is negative 0.25 volt. Okay. And then when X is connected to SHE, SHE is with 0 volt because it's standard hydrogen electrode. Electron flow from X to Y. So X to Y. Okay, electron flow from X to Y, meaning that this one is anode. And then this one is cathode. Okay, so cathode is 0. Okay, and then X. So again, confirm the value of electron X is with the standard reduction potential for X is negative 0.25 volt. Okay, after that, how are you going to explain this question? Are the inert value of the half cell positive or negative? Okay, so you have to mention like this. Okay, electron flow from X to SHE. X undergo oxidation. So the E node for the standard reduction potential of X is negative. Okay, and then electron flow from X to Y. X undergo oxidation. So the standard reduction potential for X is more negative than the standard reduction for Y. So Y is positive. Okay, So meaning that again, the value of X standard reduction potential for X2 plus to X is negative 0.25 volt. Okay, now we go for the second one. What is the standard electromotive force? Okay, actually it's same, same meaning of standard E-node cell, sorry, is same as E-node cell of a cell consisting S and Y electrode. So again, apply the formula E-node cathode minus E-node anode. Since we know cathode is this one more positive, cathode is more positive, so Y is cathode, and then X is anode. Okay, so you know, okay, so you just substitute and then you get the answer positive 0.59 volt.